Hey, in this short video, I'll give you all an update of the new features available in Whitson PBT, and we'll just jump straight to it. Under the wells view now, if you are a super user, you are able to both delete a particular well that's added to the database or edit one existing well. If you edit a well, you can change the well name and unique well identifier number right here. And if you want to delete it, you simply just click the delete well option right here, and you have to essentially confirm that you would like to delete this particular well. In this case, we would like to skip that. Um, if you have a wide range of wells in a field and we would like to, for instance, map that out on the map, that let's say you want to map out saturation pressures, for instance, through your acreage, formation volume factors, etc., you are now able to actually mass export all the generated fluid information by clicking this export fluid data button up to the left in the navigation panel. Going further, we've actually done a fairly significant delinking of the so-called different black oil table features we had earlier, and the way we create a fluid composition that's created or used as an input to the black oil table generation. So for those of you who remember earlier, we had a quick BOT option, we had an advanced BOT option, and also a custom BOT option. That's actually now been simplified such that it's only one BOT option, because the way we generated the actual black oil table in all those different features was the same. The only thing that was different from case to case was how we generated the fluid composition that went into creating the black oil table. So for each and every well now, you go into the fluid definition tab in the left in the navigation panel right here. And then depending on what data you have available for that particular well, whether that's just API and GOR, or if you have more data as separated gas and separated oil up to C7+, or if you actually have a full fluid composition from a PBT report, you input that here in one place, and that this fluid composition that's generated from this data is then used together with the equation of state, the reservoir temperature, and surface process to then create the black oil table for this particular well. Also very nice to see is that we have now the ability to plot the phase envelopes for different fluid systems automatically. That's found under the fluid definition pane as well, and can be exported into different formats, both to Excel and as an image if that's of interest. And obviously there's some pretty neat zooming functionality within this view right here. This is an interesting case actually, because this is a I think this is a gas condensate well, so there's only dew points on the phase envelope. But if we, for instance, change to another well, we can see a more typical phase envelope that has both phases right here and a critical point to the right here. The last updates are actually, that's worth mentioning in this short video, is done in the black oil table module itself. First of all, we've moved the export button to the top of the table, which makes a lot of sense, because this is probably the main thing you would like to do in this particular module. So we made that more available right here. And then in addition to that, we have added a additional line of cards at the top here in this summary of the fluid properties at initial reservoir conditions. And the reason for that is, first of all, to clarify what type of fluid system we're talking about, whether it's an undersaturated oil, an undersaturated gas, or a two-phase system. Also the associated dew point or bubble point or saturation pressure in general, that can be found to the right. But probably most importantly, for those of you who use the software to calculate hydrocarbons in place, we've also made a very nice number and pragmatic and practical number available to all of you, which is this total oil formation volume factor and total GOR. That can be used in a very simplistic manner to calculate hydrocarbon or original oil and gas in place for all fluid systems, whether it's two-phase oil, or two-phase or single-phase gas or single-phase oil. and then you can always use this formula. And I'll spend a little bit of time to explain that. And this is actually a very good example because we're looking at a gas condensate system, and a lot of people ask, okay, what's the formation volume factor of a gas condensate system? But the way we think about a formation volume factor for a oil system is that we have essentially hydrocarbons in place, and then we divide by the BO, or the formation volume factor. The units of a formation volume factor is reservoir barrels per stock tank barrels, or something equivalent to that. And you can actually calculate the same equivalent number for a gas condensate well, which is simply the dry formation volume factor for gas divided by this little RS term right here. And that gives you units of reservoir barrels per stock tank barrels. And the value of that is summarized right here. And if we go into the manual for this particular feature, and we go into the explanation of total oil formation volume factor and GOR, we can see how these are calculated. So for instance, the formation volume factor, the total formation volume factor for a single phase oil case would just be equal to the BO. And for a gas case, it would simply be equal to this BGD over little rs. But for a two-phase case where you actually have separate oil and gas saturations, you would have to do a saturation weighted average to come up with a representative formation volume factor, and then this particular formula right here is used to calculate that. The nice thing about that is that no matter if you have a two-phase system, a single-phase system, or of any sort, you can always use the same formula that we know from before, which is this to calculate oil in place, which is hydrocarbon pore volume, divided by this total formation volume factor number. You get oil in place, no matter what fluid system you're talking about. On the same note, in a similar manner, you can always calculate the original gas in place by calculating or using this original oil in place number and just multiply by the total GOR. That's also provided. So by just knowing the hydrocarbon pore volume, you can use these two directly, no matter what fluid system you have, and calculate the numbers that is of interest for you when it comes to reserves. And that concludes my short introduction to the new features and updates of Whitson PVT, and there will be more to come in the next months as well, so stay tuned.